Hello, welcome to Hawk Math. Today we're going to be doing the following problem. Let a, b, and c be complex numbers such that ab plus 1 over 3b equals bc plus 1 over 4c, which equals ca plus 1 over 5a, equals 2020. Find the remainder when abc plus 1 divided by abc is divided by 10 to the 6th. Now, the first thing that stands out to me is that the symmetry in this expression. We have ab plus 1, and then we have bc plus 1, and we have ca plus 1 over abc. The only difference is this 3, 4, and 5 on the denominator. Now, it also says that a, b, and c are complex numbers. This gives me the idea that we probably don't want to be solving for each variable individually because that would become really messy. So you probably want to find some way to get this expression, abc plus 1 over abc, to find what that equals using some algebra. Well, let's try rewriting this. So we know that a, b plus 1 equals, if we take 3b times 2,000, I'm just going to keep the b over here, this is equal to 3 times 2,000. Sorry, 2020, my bad. Now, you also know that by the same reasoning that BC plus 1 over C is equal to 4 times 2020. And we also know that CA plus 1 over A is equal to 2020 times 5. So we can divide out each one to get A plus 1 over B equals 3 times 2020. And then we get B plus 1 over C equals 4 times 2020. We also get that c plus 1 over a equals 5 times 2020. Now, we have these expressions that look pretty similar. What were to happen if we were to multiply all of these together? We would get a times b times c plus 1 over a times b times c plus a whole bunch of extra terms. Well, let's see what happens if we expand that and see what extra terms we do get. So if we do that, we get that a plus 1 over b times b plus 1 over c times c plus 1 over a equals, well, expanding out that first term, we're going to get a, b plus a over c plus and 1 over bc plus 1 times c plus 1 over a. Now, this is equal to abc and then plus 1 over abc. Let me write that out first. Now, doing the other terms, we get that we have a b, and then we have a plus a, and then we have a plus 1 over c, and we have a plus 1 over b. Multiplying that, we already did, and then we have a plus c and a plus 1 over a. Now, we see that we can rewrite this as a, b, c plus 1 over a, b, c, and then we have a plus a plus b plus c, but I'm going to rewrite this as a plus 1 over b plus, now we have a b plus 1 over c, and then plus c plus 1 over a, just by rearranging the terms. Now, if you notice, we know the values of these. And we also know that this whole thing is equal to the product of all these. So 3 times 4 times 5 times 20 cubed is going to be 12 times 5, which is 60, times 20 cubed. So bringing that down, which equals 60 times 20 cubed. Well, we know the values of these. We have a plus 1 over b equals 3 times 20, and then we know that this is 4 times 20, and then that's 5 times 20. So we have a, b, c plus 1 over a, b, c is equal to 60 times 20 cubed minus those added is going to be 3 plus 4 plus 5 is going to give us 12 times 20. And that's it. We have our value for abc plus 1 over abc. Now we need to finish up the problem by finding the remainder when that is divided by 10 to the 6th. Now, this isn't too fun to do by hand, but it shouldn't take that long, so let's just try doing it. I'm going to factor out a 20 times 60 times 20 squared. Then we have minus 12. Well, 20 squared, I know just off the top of my head, is going to be equal to, I'll write it down for you, 20 times 60 times 4080400 minus 12. Okay, well, 60 times that, let's do that out. So 40804 times 6 will give us 4, 2, 2. 6 and 8 is 48. That'll be a 4. And then 6 and 4 is 24. And then don't forget to add the zeros back in. And then we have a minus 12. Well, subtracting 12 from that will give us a 2, 4, 4, 8, 2, 3, 9. And then if we were to take that minus 12, that's going to give us an 8, 8. And then we have 20 times that. So I'm going to do this out over here. We have 2, 4, 4, 8, 2, 3, 9, 8, 8 times 202. This isn't the prettiest problem, but we'll get through it. So that becomes a 16. So that will become 17. 2 times 9 is 18, and 1 will make that 19. That's 7, 4, 6, carry the 1, 9, 8, and 4. Okay, then zeros all in there, so I'm going to put 0, 0 now. 2 times 8 is 6, carry the 1. 2 times 8 is 16, that's going to be 17, carry the 1. 2 times 9, it's going to be the same number. Wow, I should realize that. So that will give us a 9, 7, 4, 6, 9, 8, 4. We can add those together. So we get 6, 7, well, 6, 9 is 15, carry the 1. That'll be another 15, carry the 1. That'll be a 14. That'll be a 14. That'll be a 14. And then that will be a 15. That will be a 14, 9, and then 4. And then don't forget to add the 0 because this was 202. And that is the value of this. All we need to do now is divide this by 10 to the 6th. Well, if we do that, we would carry the decimal over 1, 2, 3, 4, 5, 6 places right there. So when we divide this by 10 to the 6th, we get 4,945.455760. So the remainder, when we divide by 10 to the 6th, is really just this times 10 to the 6th, or just 455,760. And that is it. Thank you for watching. I really hope you enjoyed this video. This problem was a little bit annoying to calculate out by hand, but the cool part was this algebra to get to this answer right here to show us an easy expression for our ABC plus 1 over ABC. So please like the video and subscribe if you want to see more.